Hello, my name is Maya Hoon, and I'm an Environmental Sciences and Engineering MS candidate at UNC Chapel Hill. And my thesis focuses on heavy metals as drivers of antibiotic resistance in the Neuse River. Antimicrobial resistance, or AMR, is the ability for bacteria, parasites, viruses, and fungi to resist the medicines used to treat the infections that they cause. And part of what makes this challenge so impactful is that AMR can lead to the increased difficulty to treat infections, and it leads to increased costs to treat them. And with increased resistances to antibiotic treatments, we can also expect an increase in infection-related deaths. Antibiotics, however, are not the only substance bacteria have resistances to. Research shows heavy metals are another substance that have toxic effects on bacteria. And in order to survive, bacteria started to develop these mechanisms that help them resist the toxic effects. But these resistance mechanisms can also be used to help bacteria be resistant to antibiotics as well. And that's concerning because heavy metals can have an influence on antibiotic resistance spread. And heavy metals are actually present in several orders of magnitude greater than antibiotics in the environment. Heavy metals can come from many different sources, including hog farms, feeding additives, and additionally copper sulfates, which is a metals-based pesticide and water disinfectant that's commonly used in North Carolina. So these metals get into surface water environments and increase opportunities for bacteria to develop heavy metals influenced antibiotic resistances. And this is concerning for North Carolina because AMR bacteria may infect fish in aquaculture farms in the East Coast. And because the infections can't easily be treated, not only is the economy impacted, but humans who eat the fish are at risk as well. And additionally, humans can be exposed through recreational activities such as swimming in surface waters with AMR bacteria. So to better understand the relationship between heavy metals and antibiotic resistances in North Carolina, my research aims to characterize the association between heavy metals resistant and antimicrobial resistant bacteria in the Neuse River Basin. And I had a particular interest in looking into how rainfall may impact heavy metal resistance and antibiotic resistance outcomes. So I got that data from a satellite data set. And secondly, I was interested in looking into any associations between salinity and heavy metal resistance and antibiotic resistance outcomes so that I could better understand maybe if there are more targeted areas we should be focusing AMR monitoring efforts on. So for example, Eastern North Carolina versus inland North Carolina, where there are less saline waters. And between August of 2021 and November of 2021, I took water samples from 4 different locations. The Neuse River estuary represented my more saline site, and then the Morgan Creek, Eno River, and Neuse River at Raleigh represented my less saline sites. And after I got bacteria out of water samples, I performed antibiotic resistance assays, which is basically just seeing which antibiotics bacteria were able to resist and not be killed off by. And then I would do a similar kind of test, but with heavy metals instead. And I focused on using copper and zinc because of their prevalence in surface water environments. To obtain my rainfall data, I used a satellite data set provided by USGS called CHIRPS Daily. And I would collect precipitation data 7 days from before the day of my sampling trips, 3 days before, and 2 days before. And then I'd calculate the rainfall intensities for that time frame to use for statistical analyses. And for this work, I performed logistic regressions to see if there were associations between antibiotic resistance and metals resistance, antibiotic resistance with rainfall, metals resistance with rainfall, and then different salinity levels with the antibiotic resistance outcomes. And overall, we found that increases of metal resistance had an association with increased antibiotic resistance in 4 different antibiotics. And no associations were linked with rainfall intensity. And finally, there may be associations of increasing salinity on antibiotic resistance outcomes, as we found that different salinity levels had an association with antibiotic resistance, but not on heavy metal resistance. And for future work, we want to study these same relationships, but for more specific bacteria species and compare the results across species. Additionally, we're hoping to collect more isolates for this study to have more variability, such as with rainfall events. We want to get more varied rainfall events, maybe a high rainfall event and a low rainfall event to better understand how rainfall may affect our variables. And I would like to thank my advisor and committee members. And of course, thank you very much, NC Space Grant and NCC Grants Joint Fellowship, for supporting my studies and for supporting my work. Thank you very much.